Hello class, today we are going to cover our last section in chapter 3, section 5, which is proving lines parallels. So our objectives today are to recognize angle pairs that occur with parallel lines and to prove that two lines are parallel using angle relationships. All right, so we have some postulates, and so these are statements that are going to prove why things happen. So our very first one is going to be the converse of corresponding angles postulate. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So really what this is saying is that in the previous sections in this chapter, we knew lines were parallel, and because the lines were parallel, we could say the angles were congruent. Here we're looking at and saying, well, because of corresponding angles are congruent, if they all are, then if they are, then we know that these lines are parallel. So we can say that if angle 1 is congruent to angle 3, then A is parallel to B. Or I could say if angle 2 is congruent to angle 4, then A is parallel to B. I could say if angle 5 is congruent to angle 7, guess what? Then angle A is parallel to B. Or, my last one, if angle 6 is congruent to angle 8, then A is parallel to B. So if any of these corresponding angles are congruent, then I know that my two lines are parallel. And it just needs to be one set of my congruent angles. All right, so let's see how we put that to use. So given the following information, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or the theorem that justifies your answer. So I could say angle 1 is congruent to angle 3. So we find angle 1 and angle 3. And if I'm looking at those, I know angle 1 is a corresponding angle with angle 3. And if they're congruent, I can say A is parallel to B, and it's by my corresponding angles converse. Converse is just saying that it's saying that my angles are congruent, so my lines are parallel. Okay? All right. So parallel postulate. If given a line and a point not on the line, then it exists exactly one line through that point that is parallel to the given line. So I have my line M and my point P, and I know that there's only one possibility of a line to go through there that's going to be parallel to line M. Just one, just like we know that there's one line that would go through that would make it perpendicular. All right, so here we're going to come to this page. We have 4 different converses. I'm going to pull it up. I expect you to pause that while you write, and then I'm going to go right into describing it. So alternate exterior angles converse. So go ahead and pause right now. When you're done, hit play again. All right, so I assumed you paused so you could write. So here we're looking at angle 1 and angle 3. These are alternate exterior angles. They're on the outside of the two lines, and they're alternate, so they're on each side of the transversal. If those are congruent, we know that so if angle 1 is congruent to angle 3, then P is parallel to Q. All right, again, my expectation is you pause right now to write down our next converse. All right, so here we're talking about consecutive interior angles. Remember, consecutive means that they are right next to each other. So here, if angle 4 plus angle 5 equals 180 degrees, we know that these are supplementary. And if they are supplementary, then P is parallel to Q. So remember, we're just going backwards. Last time we said these are parallel, so then we know these angles have to be supplementary. We're going the opposite way this time. All right, next one is alternate interior angles converse. So go ahead and pause right now. All right, so assuming you pause to get all the writing down, now we look at angle 6 and angle 8. Those are alternate because they're on opposite sides of the line, and they are interior because they're in between P and Q. So if angle 6 is congruent to angle 8, then P is parallel to Q. And the last one on this page is our perpendicular transversal. So go ahead and pause so you can write that down. All right, so now looking here, if we know that a line R makes two right angles, one with line P and one with line Q, then, so if R is perpendicular to P and R is perpendicular to Q, then P must be parallel to line Q. So with these four postulates or converses, if you didn't get them, write it down, star it, so you can come with questions tomorrow for class. All right, so let's put this information to use. So given the following information, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or the theorem that justifies your answer. So here we're looking if angle 1 is congruent to angle 6. So I find 1 and 6. Those two I can see are on the exterior of my lines, and they are alternate. One is on one side of P and the other one's on the other side. So if angle 1 and 6 are congruent, I know that L is parallel to N, because I see my line L, my line N, they're on the opposite outsides of those. So that's by my alternate exterior converse. All right, so number 3 states in your notes if angle 2 is congruent to angle 3. So if angle 2 is congruent to angle 3. Now I notice that both of these are inside L and M, and they are alternate, so they're on other sides. If those two are congruent, I can say that L is parallel to N, not M. Let's make that look a little more like an N. Okay, so here I'm dealing with line N, or L and M. So I can say that those are parallel by alternate interior converse. So really, all I'm looking for, converse, is that those angle relationships are there. Once I know the angle relationship, I can tell you what the postulate is. All right, so let's do one more together, and then 5 and 6 I'll have you guys do on your own. So angle 2 is congruent to angle 8. Now we're looking at a different picture. So I look, here's my angle 2, and here's my angle 8. So I can tell I'm dealing with lines A and B. These two are inside A and B, and they're on alternate sides. So I can say A is parallel to B by alternate interior converse. All right, so the next two are yours to come with for class tomorrow. So angle 3 is congruent to angle 11, and angle 1 is congruent to angle 15. So give those a go for tomorrow. All right, so in the ladder shown, ooh, that picture is not there. Give me a moment. Okay, there's your picture. In the ladder shown, each rung is perpendicular to the two rails. If it is possible to prove that the two rails are parallel and that all of the rungs are parallel. If so, explain how. If not, explain why. So here is a rung. That's these lines right here. These are rungs. Okay, and then our sides are these obvious sides here. We have one side and two sides. So if I know each of my rungs is perpendicular to the two lines that it cross. So remember, think back to our perpendicular transversal converse. It says in a plane, if two lines are perpendicular to the same line, then they are parallel. Okay, so here my bottom rung is perpendicular to my other two. So I know that those two are parallel. Both are perpendicular. So since both rails are perpendicular to each rung, and I can see that by all my little boxes here that tell me that they're perpendicular on both sides, then the rails are perpendicular. Because of that perpendicular transversal converse. So perpendicular transversal converse. So it's telling me that my lines, my rungs are perpendicular to my rails, so I know those are parallel, and if every rung is perpendicular to the parallel lines, those are also parallel. All right, the last one I want you guys to do for tomorrow, now pay attention, think about what are my angles inside there when you're working on this problem. And we'll see you guys tomorrow with this done.